So adding on to what we did in 33, here's 34, similar type question. But this time we're going to have a score between 400 and 550. Again, using that the mean, this, and the standard of 500, the standard deviation is 100. So we can use the same approach. So I guess we could come here and we can change this slightly to -3.9. That way, when you go back to the graph, it's cleared out. Oh, and I also see, let's go here. Part of the problem is I need to get this turned off, right? That off. And go to our distribution, back to the calculation screen. Quick way is to do a normal CDF. We can, in this case, put the lower bound as 400, the upper bound as 550. Is that right? Yes, 550. It remembers the mean and standard deviation from the last one, and we get it, and that's 53%. 0.5328 because they want 4 decimal places. Using the normal CDF. And again, we can do the same thing to get the z-scores. So we had a lower z-score is going to be 400 minus 500 over 100. And those are the mean and the standard deviation. Z is x minus the mean divided by the standard deviation. That's going to give us -100 over 100. So that's one standard deviation, -1 standard deviation, so standard deviation below. And then the upper end is going to be 550 here, minus 500 over 100. So we get a positive 50 over 100, which is 0.5, positive 0.5. So we go from -1 to 0.5, and we can do that with the draw. Again, it gives us the visual of what we're looking for as well. Distribution, let's go over to the draw function, shade the normal. We want the lower end to be -1, the upper end to be 0.5, and we've standardized it, so now our mean is 0 and our standard deviation is 1. We'll leave it in red. We'll draw this out. There it is. Draws up, and there's the 0.5328, exactly what we got with the other one, but this one gives us the picture of what kind of a distribution we have, how we're sitting around the mean, and maybe is a little bit more powerful, I would say. That's 34.